All right, now we're going to look at second law with friction involved. So this is a lot like the one we did without friction, but this one now has a coefficient of friction of 0.1. Interesting note here, notice there's no units on the coefficient of friction. It is a unitless number because it is based on a ratio. All right, so let's go ahead and solve this problem. So again, it's a Newton's second law problem. So what we need to do is we need to generate a free body diagram. We need to draw a free body diagram. We need to identify all the forces acting. And so the easiest one, of course, is gravity. So we have mg acting down. It's being supported by a surface, so there is a normal force. And then there is this 24 newtons. And then there's also going to be friction in this case. Now, we can assume that this 24 newtons is going to pull it this way, so friction is going to resist that sliding motion, and so we're going to have friction acting this way. Now remember, ideally, these arrows should be relative in size to the size of the force. Okay, so keep that in mind when you're drawing them. Also, this 24 newtons is at an angle. Okay? What we want to do is we want to resolve that into components because we want all of our forces to either be in the x direction or the y direction. That's how we add vectors. We have to first look at their components. All right, so let's go ahead and resolve that into components. So I have 24 cosine of 20 and 24 sine of 20. My next step, and again, you don't have to do this one, is I'm going to redraw this free body diagram, but this time just include those blue arrows. All right. So here we go. We have mg acting down. We have the normal force acting up. We have 24 sine of 20 acting up. We have 24 cosine of 20 acting to the right. And we have the force of friction acting to the left. Now I guess if I was going to be trying to keep my sizes relatively the same, maybe something more like this would work, so that these two arrows would have the same length as that one. All right. Let's go ahead and generate our equations because this chapter we have to make our equations, and we start with Newton's second law or first law. This is a vector equation, so we will have to break it into a sum of the forces in the x direction, and I'm going to give myself some space here, sum up the forces in the y direction. And I have to decide where is that acceleration going to be. Ideally, I want it in just one direction. I only want it in the x or only in the y. And so if I look at my problem here, it's pretty safe to say that with 15 kilograms, roughly 150 newtons in weight, a 24 newton force isn't going to lift it off the table. So it's going to not be accelerating off or into my surface. So the acceleration in the y direction is going to be 0. Assuming this is moving, or it will be moving, we're going to say the acceleration is in the x direction. And I've set my coefficient of friction low enough that it will be accelerating to the right, and I want to figure out what that is. So I'm going to set my acceleration in the x direction to be ma. Now this is the x component of the acceleration, but because there is no y component, this is the total acceleration. Now I'm going to use my free body diagram to generate the equations. So this left half, the sum of the forces in the x direction, comes from all the forces in the x, or this sum of the forces in the y comes from all the forces in the y. So here we go. In the x direction, I have 24 cosine of 20 minus the force of friction. Why is it minus? I thought you said add up the forces. Well, I'm subtracting it because it's pointing in the negative direction. So it's another way you could think about it is that plus a negative force of friction equals ma. In the y direction, I have normal force plus 24 sine of 20 plus a negative mg equals 0. Again, there's that negative. We're going to get in the habit of changing that to just a minus instead of doing plus negative every time. All right. When we have friction problems, a big thing here is we are going to typically substitute. Unless they tell me the force of friction value or I'm trying to find it, we're going to make a substitution here. Since they gave me the coefficient of friction, yes, I'm going to substitute. So I have 24 cosine of 20 plus, oops, we're going to change that to a minus, and I'm going to substitute mu times the normal force. Okay. This is what the force of friction is. To be specific here, I have a kinetic coefficient of friction equals ma. Next, we're going to substitute for normal force. If there's a mantra you want for doing friction problems, substitute, 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 okay? So where do I find the normal force? I'm going to find the normal force over here in my y direction. So the normal force is equal to mg minus 24 sine of 20. I'm now going to take this and substitute it in there. This equation is going to be huge. 24 cosine of 20 minus mu times mg minus 24 sine 20 equals ma. All right. The last step is I'm going to divide by m and solve for a. So I'm going to divide both sides by m. M is going to be 15, mu is 0.1. So if you plug in your numbers, you should get an acceleration of 0.58 meters per second squared. And if you're watching these videos in order, it was 1.5 meters per second squared without friction, so now it is less when I apply friction.